Welcome to my presentation. This presentation is part of the playlist The Chain Rule. In this presentation, we will be solving problems using the chain rule. Let us look at some example problems. If we have a problem like this, y equals to 3x minus 2x squared, the whole thing raised to the power of 3, and if we want to find the derivative of this complex function, we can use the chain rule. Let us first of all divide it into two parts, the inner function and the outer function. The inner function here is 3x minus 2x squared. Let's call that as u. Let u be equal to 3x minus 2x squared, and therefore the outer function y will be equal to u to the power of 3. We have divided this complex function into two parts, the inner function and the outer function. We can differentiate each of these functions separately and then apply the chain rule and then arrive at our solution. Let us see how that works. So we're going to differentiate u with respect to x. Why? Because u is a function of x. We're going to differentiate y with respect to u because y is a function of u. Okay, let's start here. U is equal to 3x minus 2x squared. Differentiating with respect to x. du by dx is equal to d by dx of the same thing. I just wrote this down here, 3x minus 2x squared. So d by dx, the differential of 3x is 3. The differential of 2x squared, we're going to use the chain rule here. 2 comes in front of the function. Then the power rule states the exponent comes in front of the function, and then x to the power of 2 minus 1. So when we simplify it, it's going to be 3 minus 2 times 2 is 4x. Okay, so we have differentiated the u function with respect to x successfully. Now let us look at the other one here. Y is equal to u cubed. We're going to differentiate this with respect to u. When we differentiate y with respect to u, the u cubed, so we can use the power rule here. So we have a power 3, so that comes in the front of the equation, times u to the power of 3 minus 1. So therefore, this, when we simplify, it's going to simplify to 3u squared. We have dy by du as 3u squared. We have du by dx as 3 minus 4x. Now we are ready to use the chain rule. The chain rule is stating that dy by dx is equal to dy by du times du by dx. We have these individual differentials simplified here, and we're going to put them together here. Dy by du is equal to 3u squared, and then du by dx is 3 minus 4x, like here. So therefore, when we simplify this, we're going to have what I have done here is I've distributed the 3 to every one of the terms inside the parentheses. 3 times 3 is 9, 3 times negative 4x is negative 12x, and then we have the u squared. We cannot have u as part of our solution. So what we need to do is we need to substitute back what we have started to say u is equal to. We said u was equal to 3x minus 2x squared. So we're going to substitute that wherever we see u, and then we can simplify the solution as shown here. So 9 minus 12x, nothing changed there. Instead of u, we are now writing 3x minus 2x squared inside the parentheses, and u is raised to the power of 2. Therefore, this whole expression is raised to the power of 2. And this is our solution. This is how we're going to use the chain rule to solve example problems. Let's look at another example. Let's say this time we have y is equal to 6x minus 5, the whole thing raised to the power of 4. So here again, since this is a complex function, we're going to divide it into two parts, the inside function and the outside function. If we call the inside function as u, the outside function then becomes y equals to whatever we call the inside function as. So let us call u as equal to 6x minus 5. Then the outside function y we can write as u to the power of 4. Now we have two different functions. As you can see, u is a function of x and then y is a function of u. We can differentiate them separately and then use the chain rule to arrive at the answer. So du by dx, when we differentiate this function, du by dx is equal to 6x minus 5, d by dx of 6x minus 5. D by dx of 6x is 6, d by dx of negative 5 or d by dx of 5, which is a constant, is going to be equal to 0. So when we simplify it further, this is going to be equal to 6. So therefore, now let us look at the other function, y equals to u to the power of 4. When we differentiate this, we can use the power rule here. And then when we use the power rule, u to the power of 4 simplifies to 4 u to the power of 4 minus 1. And then when we simplify it further, it is going to be 4u to the power of 3. Now we have differentiated these two functions successfully. We have the value of dy by du as 4u cubed, and we have the value of du by dx as equal to 6. Now we can use the chain rule and put these together and simplify and then arrive at the answer. So dy by du is 4u cubed, that's what I wrote here, and du by dx is equal to 6, and that is what we wrote here. Therefore, when we simplify this, 4 times 6 is 24, and we have u to the power of 3, but we said u is equal to 6x minus 5. Wherever we see u, we're going to substitute the value of 6x minus 5. Therefore, we have 22 times 6x minus 5 within parentheses, the whole thing raised to the power of 3, and that is our solution. This is the way we're going to use the chain rule to solve example problems. Let's look at another example. Let's say this time we have y is equal to, we have a function y equals to x squared plus 1, the whole thing raised to the power of 4 over 3. We want to find the derivative of this complex function, and we want to use the chain rule whenever we have situations of this kind. So here again, we're going to divide it into two parts, an inside function and the outside function. The main thing in here is to recognize what the inside function is and what the outside function will be. So the inside function here is u. Let u be equal to x squared plus 1, and therefore the outside function y will be equal to u to the power of 4 over 3. Now we have two functions. We can differentiate these functions separately, combine them using the chain rule, and arrive at our solution. Let us see how that works. Here, u is a function of x, as you can see that, and here y is a function of u. We're going to differentiate u with respect to x. Du by dx is equal to d by dx of x squared plus 1. So d by dx of x squared, we can use the power rule here. When we use the power rule, it simplifies to 2x to the power of 2 minus 1, and d by dx of 1, which is a constant, is equal to 0. So when we simplify this further, it is going to be equal to 2x. 2 minus 1 will be 1, so x to the power of 1 is x, so therefore we can just leave it as 2x here. On the other side, we have y as a function of u, so we're going to differentiate it with respect to u. So d by du of d by du of u to the power of 4 over 3, we can use the power rule here, and when we use the power rule, the exponent comes to the front of the equation, 4 over 3 times u to the power of 4 over 3 minus 1. So when we simplify it further, it is going to be 4 over 3 times u to the power of 1 over 3. So we have successfully differentiated these two functions, and we have the value of dy by du, and we have the value of du by dx. Now we are ready to apply the chain rule for this particular example problem. Dy by dx is equal to dy by du times du by dx. So we have the value of dy by du as 4 over 3 times u to the power of 1 over 3, which is this. And then du by dx is 2x, and that's what we have written here. So now we're going to simplify this. 4 over 3 times 2 is 8 x over 3 times u to the power of 1 over 3. But we said u is x squared plus 1. So wherever we see u, we're going to substitute x squared plus 1. Therefore, when we simplify it further, it's going to look like this. 8x over 3 times x squared plus 1, the whole thing raised to the power of 1 over 3. And this is our solution. This is how we're going to use the chain rule to solve example problems. In my next video presentation, we will be solving more problems using the chain rule.